Hello everyone, I hope you all did well today. So, myself Mridul Agrawal and I am currently pursuing my masters from IIT Roorkee, and I will start my topic today on matrices and determinant. As you can see, I will start with the definition of matrix, then I will see some examples, then we will go for the type of matrices, and then we will learn about these type of matrices. Now, what is matrix? So, a set of mn numbers arranged in a rectangular array is called a matrix, and we usually denote it by these symbols. Now, we will see some examples of matrices and how a matrix is formed. So, we will give a general example like A11, A12, and so on, A1n, A21, A22, and so on, A2n, and similarly AM1, AM2, and so on, AMN, here with order m cross n. Here mn elements are there in this rectangular array, and order of this matrix is m cross n, and we denote it as m cross n. This is order of matrix, and each elements aij. Here I represents number of row and j represents number of column. So for A to 2, here we have I is equals to 2 and j is equals to 2. So our row is second, as you can see, and our column is also second. Similarly, we can see for A2n, our row is same second and our column is nth. So now we will construct some matrices, and then we will go for the matrices at other examples, like construct a matrix of order 2 cross 3 where each aij is equals to I minus 2j. So we have to construct a matrix of order 2 cross 3 and aij is equals to I minus 2j. So now we give a general matrix of order 2 cross 3, which is A11, A12, A13, A21, A22, A23, and its order is 2 cross 3. Here we have to form 2 cross 3 order matrix, so we formed it. Now we want to find these each entries. And how we will find this? Because we have given aij is equals to I minus 2j. So A11 will be what? A11 is equals to 1 minus 2. 1 minus 2, which is equals to minus 1. Similarly, A12 is equals to 1 minus 4, which is equals to minus 3. A13 is equals to 1 minus 6, which is equals to minus 5. And similarly, we can find for A21, A22, A23, which will be what? 2 minus 2, 2 minus 4, 2 minus 6, and these are equals to 0, minus 2, and minus 4. Now we can construct our matrix A using these all 6 elements. So our matrix will be what? A is equals to A11 is what? Minus 1, A12 minus 3, A13 minus 5, A21 0, A22 minus 2, A23 minus 4. So this matrix A of order 2 cross 3 is our matrix constructed from aij is equals to I minus 2j. Now here how many elements are there? 2 cross 3 is equals to 6. 6 elements are there in our matrix. Now if we have given a order of matrix and we want to find how many matrix can be formed from that order of certain order, then how can we form? So we want to find, so we have our next example, how many matrices can be formed of order 3 cross 3 using 9 distinct elements. So in this question, I want to form our matrix of order 3 cross 3, and all the elements of these matrix are distinct. So I will use this general matrix A of order 3 cross 3. So it will have 9 entries, and for to fill these 9 entries with 9 distinct elements, how many matrices will be there? With NCR, I have 9 factorial ways to fill this, so I can form 9 factorial matrices of this kind. So now I can further add another details in this, and instead of distinct elements, I can fix my elements like if how many matrices can be formed of order 3 cross 3 using, I will erase this distinct elements part, and I will give some using elements, some elements like 0 0 0 0 and 2 2 2 2 2. So here I fixed our elements which we have to use to form our matrices of order 3 cross 3. So how many matrices will be formed? Similarly, if we form A of order 3 cross 3, and we have to fill 9 entries, and from previous question we know if we have distinct elements, then how many matrices we can form? 9 factorial matrices. But here our matrices elements are fixed, like 0 4 times 0 and 5 times 2. So if we have some fixed elements of same type, then we divide with that number, like we have 4 zeros, so we divide with 4 factorial, and we have 5 twos, then we divide it by 5 factorial, then this will be the answer of our question. These many matrices will be there formed from 4 zeros and 5 twos. Now you can ask, like, how are these 4 factorial and 5 factorial coming here in our question answer? So like I will form a general matrix of these with these elements like 0 0 0 0 2 2 2 2 and 2, and this is of order 3 cross 3. Now see, if I change my AI A11 with A13, or either I change my A31 with A33, is there any difference with my matrix? See, no, there is not any difference, because, or further I can say, if I change any 4 zeros with each other, then there will be not a change. And similarly, if I change these 5 twos with each other, there will be not any change in our matrix. So this is just an example. So how many ways are there to form these arrange these 4 zeros? There are 4 factorial ways. Similarly, for these twos, there are 5 factorial ways. So how many ways are there? We have to remove 4 factorial into 5 factorial ways. So similarly, for such kind matrix, we have all the kind 9 factorial matrices. I have to remove these kind of matrices from our solution. So I have to divide it by 4 factorial and 5 factorial, and then we get our solution as such. Now I have another example for you, like an example, how many matrices can be formed of order 3 cross 3 using elements Now I will fix another thing here. Instead of these, I will use elements 0 and 1 only. But I want another condition that what will I add? And sum of each row is 1. Now I want how many matrices I can form with element 0 and 1 and sum of each row is 1. So I want sum, like I will take first row, then I want sum of this row is 1. So I can fill these from these three entries only one entry with 1, and I have to fill other two entries with 0, because if I fill other entries with 1 then sum will be greater than 1. So there are only one possibility to fill from these three possibilities, so I have to choose one entries from these three. So I have 3C1 matrices from for this first row, and for other two elements will be 1 into 1. Similarly, for second row, I will have 3C1 into 1 into 1. Similarly, for third, 3C1 into 1 into 1. So how many matrices can I form? 3C1 is equals to 3. This is also 3. So total number of matrices is equals to 3 into 3 into 3, which will be equals to 27. So I can form 27 matrices of such kind. So I hope you like this example, and this kind of examples are very most important for JEE-MAINS, because here we are combining our permutation and combination and matrix in each other with one example. So such kind of examples came many times. So we will go further for our types of matrices. So we have first row matrices in our types of matrices. What are row matrices? If first row matrices, if we have only one row in a matrix, then it is called row matrix. And we write row matrix and as denote order it as 1 cross n, because what it is denote m as row and this is column, so we want only one row. So this is the order of row matrix, and we can give an example like a11, a12 and so on, a1n of order 1 cross n. So this is of our definition of row matrix. Similarly, we can give our definition of column matrix. Column matrix is what? Only one column. So what will be the order for column matrix? Yes, it is m cross 1. We denote it as m cross 1. And example, general example, a11, a21 and so on, am1 of order m cross 1. Now we will go for null matrix. As name suggests, it will be null. So null matrix is what? If all the entries are 0 for any matrix, then it is called null matrix. So, and its denotation, we denote it as this is its symbol. So I will give an example. Funnel matrix. Example for null matrix will be what? A1 1, but each entry is 1. So 0 0 and so on, 0 0 0 and so on, 0 0 0 and so on, 0 of order m cross n. This is our null matrix. So now we will go for horizontal matrix, vertical matrix and square matrix. How we define horizontal, vertical and square? We know order of our matrix is what? M cross n. According to M cross n, we define our matrix in horizontal matrix, vertical matrix and square matrix. And this square matrix is most important for us, and we will learn more about this square matrix in next lecture. But first we will cover these. So what is if we have three possibilities: m is less than n, m is greater than n, or n is equals to n. If m is less than n, it means number of row is less than number of column. It means number of row is greater than number of column. It means number of row is equals to number of column. So if number of row is less than number of column, then how will it form? Like a11, a12 and so on, a1n, a21, a22 and so on, a2n of order 2 cross n. And if number of row is greater than number of column, how will it form? a11, a12, a21, a22 and so on, am1, am2 of order m cross 2. You can simply see that this is a horizontal type, so this is called horizontal matrix. This is a vertical type, so this is vertical matrix. And what if m is equals to n? This is a11, a12 and so on, a1n, a21, a22 and so on, a2n, an1, an2 and so on, ann of order n cross n. Here our m is equals to n. So this is of square matrix. Now square matrix is also divided in three parts: upper diagonal matrix, lower diagonal matrix, diagonal matrix. So first we have to know about what is diagonal. So in a square matrix we can see that we can form a diagonal, like we can form aii. We have aii, a, or we can say aij in such a way I is equals to j. If so, these all entries are diagonal entries, and this is called diagonal. So according to this diagonal, we divide our square matrix in these three parts. If all the entries below diagonal is 0, then it is called upper diagonal matrix, because all the entries are in upper part. And if all the entries of upper part is 0, then it is called lower diagonal matrix. So I will give an example like 2 3 4 5 6 0 0 0 7. See, above diagonal, all the entries are above, so this is of type upper diagonal. And if I give 2 5 6 7 3 4 6 0 0 0, this is lower diagonal. And if I combine these two, upper diagonal and lower diagonal, then this is form diagonal matrix, like 2 3 4 0 0 0 0 0 0. This is of diagonal matrix. So I hope you liked this video, and I think I covered all the concepts regarding this. So I think, and further this we will see in next video. Thank you.